In this example, we'll use prime factorization to help us determine the greatest common factor. For part A, let's start by determining the prime factorization of 90. As I break it down, I'm going to get a list of all of its prime factors. In this case, it's 3, 3, 2, and 5. 2 times 3 times 3 times 5. I'm going to compare that prime factorization with that of 225. Again, use any factors that are obvious to you. I used 5 and 45. And then I continued to break down 45. When I list that prime factorization, I have 3 times 3 times 5 times 5. In order to determine the greatest common factor, I need to see which prime factors these two numbers have in common. 2, for example, is not in common because only 90 has that. But I see 2 3s that can be matched up and 1 5 that can be matched up. So I know that of the prime factorization of 90 and 225, what they have in common is 3 times 3 times 5. If I multiply those numbers together, I'll get 45. 45 is my greatest common factor of 90 and 225. Let's try another. 154 can be broken down to determine its prime factorization. I have 2 times 7 times 11. The same can be done with 198. I use 2 times 99, 11 times 9, and 3 times 3. So 2 times 3 times 3 times 11. Now remember, the key is to find out which prime factors they have in common. So they each have 1 2, and they each have 1 11. The 7 they don't have in common, and these 3s they don't have in common either. So the greatest common factor can be found by multiplying 2 times 11, or 22. The greatest common factor between 154 and